Hello, I'm Nem, and this is my Physics 1 lab. So today the purpose of our experiment is to investigate the differences between observed position in time and also computed position in time, and the interactions of an object moving with constant velocity and a net force ultimately of zero. So the fundamental physical properties, which we're going to go into later, is delta t, which is the change of time between data point 1 and 2, which will be repeated throughout the whole experiment, the direction of motion of the system, which leads to the velocity vector, which again is constant, the position vector, which is going to be used to find the initial velocity in the coding, and then the net force and forces, which must be equal to each other when they oppose in order to get a velocity vector of constant. And so also a little bit more with the main result preview is that the positions are going to be both linear and they're going to be very similar because it is a constant velocity with no net force, so the calculations can't be too crazy from each other. So the first thing I'll show is just the system itself, which is me just riding on my scooter by the Kalk. So this is the observed position versus time. So the red line is going to be the y-axis, which if you saw in the video, there was a teeny bit of a hill, so I did include the y-axis, and then the x-axis is just very linear, and it is just the data points of my position over time. And then the computed position over time is done by coding, so it is literally a perfect straight line. And if you want to see the coding, it's right there in the link if you would like to type that in. And there's not really much to say about this, and as you can see from the graph, the velocity is constant. And then when we put the two graphs together, they are, again, super similar, and that's just because there weren't too many variables which were changing. But we are going to talk a little bit in errors later about why they are different like they are. So the main ideas are going to be connected to Newton's second law. So basically, delta t and m are both scalars, and m is mass. And so the mass of the system was 195 pounds because I weigh about 130 and then my scooter weighs about 65. And then delta t was 0.017 seconds. And because those are scalars, if delta v or f net is 0, then the scalars are not going to matter because it's just multiplying 0, which obviously can't amplify it. And then also the change of velocity is going to be v final minus v initial, and if v final and v initial are constant, then they're the same, which again will be 0. And then this is my free body diagram, which I drew up just to show that the forces going this way were equal to each other. So F final minus F initial are going to be 0, and then the forces going this way also are going to equal each other. So the net force is ultimately 0, and then in the middle is just me on my scooter. And then this was the coding, which again at the top, ball dot m is going to be the mass, and then the position vector, I just chose the first data point, which was right when my front tire hit the video. So I used the tracker in my front tire in order to track my position. And then the velocity vector, I did delta t divided by delta r, which is change in time over change in position, in order to find v average. And then delta t was just the time between each time frame that I took a data point. And f net is equal to 0, velocity is equal to velocity plus v net, etc. And then for my findings, so the system were my scooter and myself, and then the surroundings were, because it was an open an open system, there were a lot of like random forces that could have affected it, but I think the main ones were the wind / air resistance, and then the tire was hitting the ground, so there was definitely friction. And then the temperature was pretty cold, so sometimes my scooter doesn't run as nicely in the cold, so the machine might have had a little bit of unreliability. And so all these forces can contribute in some way. But even though these are like individual forces, they aren't affecting the net force by making it not 0 because they're just exactly equal to each other. So like if this is 5, this is also 5, so 5 minus 5 is going to be 0. And then if I had decided to like make the graph kind of like a absolute value of x, it would have gone like this, which would have given me total area instead of net area, so I would not have wanted to do that, and that's kind of just a calculus thing. And then some errors is that I couldn't figure out how to do auto tracker on the tracker app, so I individually clicked every single frame, and I got kind of tired towards the end, so the graph kind of lingers off towards the ends. And then also, I was the person controlling the scooter, so there obviously might have been errors there. And I also couldn't really find anywhere that was super flat, and so the y-axis preferably would not have been in the equation at all, but it had to be because I was on a hill. And that's all I have today. Thank you so much for watching, and enjoy your day.